Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The susceptibility of a carbon-halogen bond to nucleophilic substitution depends on the strength and polarizability of the CX bond. A weaker, more polarizable CX bond is more easily broken by an incoming nucleophile. Moving on to the next step. As we go down the halogen group, FCl-Bri, the CX bond becomes progressively weaker because the halogen atom becomes larger and the overlap with carbon's orbitals decreases. Bond dissociation energies, CF-CCl-CBr-Ci. Moving on to the next step. Larger halogens, IBr-ClF, are more polarizable, meaning the electron cloud is more easily distorted, facilitating the transition state in nucleophilic substitution. And for the final step, the leaving group ability follows the order IBr-ClF because iodide is the most stable leaving group, weakest base, most polarizable, most stable as an anion in solution. A. To fluorobutane has the strongest CF bond and fluoride is the worst leaving group, least susceptible. B. To chlorobutane has a stronger CCl bond and chloride is a poorer leaving group than bromide or iodide. C. To bromobutane has a weaker CBr bond than CCl, but still stronger than Ci. D. To iodobutane has the weakest Ci bond and iodide is the best leaving group among the 4 halogens listed. 2-iodobutane has the most susceptible carbon-halogen bond toward nucleophilic substitution because the Ci bond is the weakest and I is the best leaving group. Therefore, the correct answer is D. Therefore, the correct answer is option D.